Mr. Sutton here, bringing you the AB Calculus 3-5 Extra Practice Number 1 solutions on product and quotient rule. On this problem, we're trying to figure out the derivative of this thing without a product or quotient rule. That means we're going to have to simplify this and use the power rule. So I'll start by turning this into x to the 1/2 times all that other stuff, distributing my x to the 1/2, so adding the exponents here. We've got 2x to the 5/2 minus 5x to the 3/2. Now, using my power rule, 2 times 5/2 is just going to be 5 for the coefficient, and we'll have x to the 5/2 minus 1, so that's 3/2. Next, we're going to have 5 times 3/2, so that's 15/2 for our coefficient there, and we'll have x to the 1/2, and that's our derivative. To figure out the derivative of this without using a product or quotient rule, we're going to have to simplify by dividing all these terms by the cube root of x, which is really just x to the 1/3. So we're going to be subtracting some exponents. This is x to the 2 minus 1/3, so that's x to the 5/3. Next, we have x to the 3/3 over 1/3, so that's minus x to the 2/3. And then finally for this, this will just be 1 over x to the 3rd, so x to the negative 1/3. Going through now and using our power rule, we've got 5/3 x to the 2/3, followed by, this will be negative 2/3 x to the negative 1/3. So we're just subtracting 3 over 3 in the exponent. And this last one will be minus 1/3 x to the negative 4/3. For this problem, if I'm trying to figure this out without a product or quotient rule, I need to distribute this term out here. So this will be 8x to the 8th, which is kind of neat. And then we have minus 4x to the 7th plus 4x cubed times 2, that's 8x to the 3rd. Using my power rule now, I've got 64x to the 7th minus 28x to the 6th plus 24x squared. To figure out this derivative without having to use the product rule, we'll FOIL this out first, distribute. So I've got negative 5x to the 9th, if I do the firsts here, and then outers is going to give me 15x to the 4th. Inners will have positive 2x to the 5th, and for the lasts, that's going to be negative 6. Just using my power rule now from left to right, I've got negative 45x to the 9th, and then this will be 60x to the 3rd, 10x to the 4th, and that minus 6 is just going to become a 0, so we won't bother writing it. And there's our derivative. On this problem, we're trying to figure out the derivative of 3 over 4x squared. Since this is a quotient when you get down to it, we can use the quotient rule. There's other ways to do this, but if you haven't learned the chain rule yet, then you can't really use those other ways. So using the quotient rule, here it is, u prime v minus uv prime over v squared. I'm going to set up my box and ribbon to help me organize all this. So I've got my u value, my numerator, which is just 3. My denominator, my v, is going to be 4 plus x squared. And now the derivatives of these, derivative of 3 is just 0, which will be really nice. And then derivative of 4 plus x squared is 2x. All right, using my ribbon to put it all together, I've got 0 times 4 plus x squared minus 3 times 2x, that's the uv prime part of it. All of that over 4 plus x squared squared, which is probably the last thing we wanted squared, but we at least see 4 answer choices that have that, so there's a pretty good chance that we're on the right track here. All right, we have to simplify a little bit, though, to get one of the answer choices. Well, 0 times all this is just 0, and we have only a minus 3 and a 6, or a 2x left, so that's negative 6x when the dust settles in the numerator. Does that match any answer choices? It does. Answer choice A. So we're calling this one done. For this problem, we're trying to find the derivative of this quotient here. So the quotient rule is a pretty good candidate on this one. Let me set that up. That's u prime v minus uv prime over v squared. And I'll set up my box and ribbon to organize all this. So I've got my numerator. That'll be 2x plus 3. I'll put that up here. And my denominator, 3x plus 2, I'll put over here. Down below, I've got their derivatives, u prime, which is 2, and v prime, which is going to be 3. Multiplying it all out with my ribbon to put it back in my fraction, I've got 2 times 3x plus 2 minus, now I'm doing the uv prime part. This is 2x plus 3 times 3. All of that over v squared, so 3x plus 2 quantity squared. I'll have to simplify this to match an answer choice. So distributing upstairs, I've got 6x plus 4. And then this will be minus, let's see, 3 times these things, that'll be minus 6x minus 9. Combining like terms, the 6x's cancel. So that's just 4 minus 9, which is negative 5. All of that over 3x plus 2 squared, leaving us with answer choice D. For this problem, they want us to figure out the derivative using a product or quotient rule. So for this one, we're going to use the quotient rule because it is a quotient. That's going to be u prime v minus uv prime all over v squared. And let's set up the box and ribbon so we can organize things. So I've got my numerator, 12x to the fourth minus 8x to the third plus 4x, right up here in the upper left. In the upper right, I'll put my denominator, 4x squared. Now I'll put their derivatives down below. So we've got 48x to the third minus 24x squared. And let's see, there should also be a plus 4 down there. There we go, that's a little more like it. And over here, our derivative of 4x squared is going to be 8x. So now, using my ribbon to put it all together, I've got all this craziness in the lower left times 4x squared. And I've got minus all this craziness in the upper left times 8x. All of that over 4x squared squared. They said no need to simplify, so we'll take them at their word and call it a day on this one. For this problem, they want us to figure out the derivative. Since there's no way to simplify this, we're going to have to go with the quotient rule, u prime v minus uv prime over v squared. Setting up the box and ribbon for that, we've got our numerator, x squared, and our denominator, 1 minus x cubed, and their derivatives, 2x, and this will be negative 3x squared. Using the ribbon to put it all together now, we've got 2x times 1 minus x cubed, that's u prime v, minus x squared times 3x squared. And let's see, I don't know why that's negative. Actually, yeah, that should be negative in my box there. There we go. That makes a little more sense now. And let's see here. We've got v squared in the denominator, so that's going to be 1 minus x cubed squared. And we didn't need to simplify, so that's algebraically equivalent to whatever the answer should be. For this problem, since I'm taking the derivative of a quotient that I can't really simplify, I am going to use the quotient rule, u prime v minus uv prime over v squared. Let me set up my box and ribbon to take care of that. So I've got my numerator, x plus 1 right here. And I guess I don't really need parentheses on that yet. And then I've got my denominator, x squared plus 1. And their derivatives now down below, I've got derivative of x plus 1, which is just 1. Derivative of x squared plus 1 is going to be 2x. Using the ribbon to multiply all this out, I've got 1 times x squared plus 1. So that's just x squared plus 1 minus x plus 1, and then in parentheses, times 2x. All of that divided by v squared, x squared plus 1, all of that squared. Now I have to simplify to get one of these answer choices. So distributing the 2x here, this is going to be negative 2x squared minus 2x. Have to combine like terms. X squared minus 2x squared, that's negative x squared. And just putting things in order, we also have a negative 2x and a 1. So that's going to match, let's see, we've got minus, minus, plus. So that's going to be answer choice C. On this problem, we're trying to find h prime of 1, given that h is f of x over g of x, and we have this whole table of f and g and f prime and g prime values. So this is a quotient rule we're going to need to use on this one. There's no other way to do it. So in general, I've got u prime v minus uv prime over v squared. That's what h prime of x is in general. And now let me set up a box and ribbon for this. So I have my numerator, f of x, and my denominator, g of x, and their derivatives, f prime and g prime. Now, if I plug 1 into all of that, let me see what I get inside my box here. F of 1, that's in the table, that's going to be 2. G of 1 is going to be 1, so that'll go over here. F prime of 1, that's going to be 1. And then g prime of 1, well, that's going to be 2 up here. All right, using the ribbon to put it all together, we've got 1 times 1 minus 2 times 2, all of that over 1 squared. They never said we had to simplify, but if you wanted to, we've really got 1 minus 4, which is negative 3, over 1 is just negative 3 when all is said and done.